Hi, so we're going to be talking about partial fraction decomposition. So sometimes you might be given an integral in the form of f of x over g of x that you can't solve using any of the other integration methods that we've learned so far. So in this case, you'd have to do partial fraction decomposition. So the way that you know that you can use partial fraction decomposition is if the top has a lower degree than the bottom and if the bottom is factorable. So for example, say you're given the problem integrate x over x squared minus 2x minus 3. So in this case, you can see that you can use partial fraction decomposition because the numerator is to the first degree and the denominator is to the second degree. So since the top is smaller than the bottom, you can use partial fraction decomposition. In addition, you can see that the bottom is easily factorable. So if we go ahead and factor that, we get this is equivalent to the integral of x over x minus 3 times x plus 1. So there you have it. You can see that we can factor the bottom. So in this case, we want to use partial fraction decomposition, which is basically breaking up that fraction into two different smaller fractions that are easier to integrate. So basically, we know that we're going to have one with the first part, this x minus a constant, and then a second fraction with the other part, this x plus a different constant. So that if you know those are going to be your denominators, so you have x minus 3, and then you know it's going to be plus another fraction with the denominator x plus 1. So we're not sure what the numerators will be yet, so we just use these placeholders a and b that we'll solve for later. So the way you can see that this is equivalent to that is if you set the denominators equal, you'll get a times x plus 1 plus b times x minus 3 all over the same denominator of x minus 3 times x plus 1. And now you see if you set that equal to this, you would get since the denominator is the same, you can rewrite that as x equals a times x plus 1 plus b times x minus 3. And now we can easily solve for a and b to find the numerators of these two fractions. So basically we try to cancel out one part at a time. So if we set x equal to -1, we can see that that will cancel out a. So then that becomes 0, so you become 0 plus -1, so you would get -4b equals x, which equals -1. So you see that b equals 1/4. And then you can solve for the a in the same way, where you just cancel out the b term. So in that case, you would set x equals 3, and then you would get a times x plus 1, so that would be 4a, and then that cancels out equals x, which would be 3. So then you get a equals 3 over 4. So now that you know the values of a and b, you can plug them back into your initial equation. So since it's a over x minus 3, you would get 3/4 over x minus 3 and plus b over x plus 1, which would be 1/4 over x plus 1. And now you can plug that back into your initial integral. So we had the integral before, so now it's the integral of 3/4 over x minus 3 plus 1/4 over x plus 1. And now we can distribute the integral and pull out these fractions. So now you know that this integral is equivalent to 3/4 times the integral of 1 over x minus 3 plus 1/4 times the integral of 1 over x plus 1. And now you can easily solve these using u substitution. So then you get your answer as 3/4 times the natural log of the absolute value of x minus 3 plus 1/4 times the natural log of the absolute value of x plus 1. And then don't forget your plus c. So now this is the answer to that integral. And you can see how breaking up a more complicated integral into two easier fractions can help you solve this equation. Okay, so next we're going to use partial fraction decomposition on a slightly harder problem. So say you're given the integral of 4 minus 2x over x squared plus 1 times x minus 1 squared. So as you can see, in the denominator we have this quadratic that we can't factor any further, and then we have x minus 1 raised to the second power. So as you can see, the bottom is to the 4th degree, so we're going to end up needing 4 different variables to solve this problem to create the partial fractions. So we'll start with the x squared plus 1. Because there's already an x squared in the denominator, we're going to need two variables in the top. So we'll create that as ax plus b over x squared plus 1, so that the top is always 1 degree less than the bottom. Next, we'll look at the x minus 1 squared. So whenever you have x plus or minus a constant to the nth power, we're going to need n different variables to solve this. So because it's raised to the second power, we're going to need two more variables. So we're going to do plus c over x minus 1. So that's n to the 1 power, or to n equals 1. And then next we'll do d over the whole x minus 1 squared. So now you can see we have four variables to match the 4 degrees in the denominator of the original problem. So now we multiply it out so that they all have a common denominator, and we set it equal to the numerator of the original equation as we did in the first problem. So in that way you get ax plus b times x minus 1 squared plus c times x minus 1 times x squared plus 1 plus d times x squared plus 1. And then so that all equals the numerator of the original, which is 4 minus 2x. So I'll save you the steps of the algebra here, and when you substitute in different variables for x, and then you get a system of equations and you solve for them, you eventually get that a equals 2, b equals 1, c equals -2, and d equals 1. So using these four values for a, b, c, and d, we plug this into the initial equation up here, and then we get 2x plus 1 over x squared plus 1, and we get plus c over x minus 1, so plus -2 over x minus 1 plus 1 over x minus 1 squared. So now we know that this equals this, and then we can just integrate these parts and in ways that we already know, such as using u substitution and trig identities. So then this becomes the integral of 2x plus 1 over x squared plus 1 minus 2 over x minus 1 plus 1 over x minus 1 squared. And now we can distribute this integral and break this fraction into two parts so that we can more easily integrate this whole problem. And then we would get the integral of 2x over x squared plus 1 plus the integral of 1 over x squared plus 1 minus 2. We can pull out that 2 times the integral of 1 over x minus 1 plus the integral of 1 over x minus 1 squared. And now if we want to integrate these parts, we can just use u substitution for this first one, which we would get the natural log of the absolute value of x squared plus 1. We realize that 1 over x squared plus 1 is just the integral of that is just arctan, so we get plus arctan of x. So this -2 just stays out in front, and we realize this is u substitution again, so we get -2 times the natural log of the absolute value of x minus 1, and then we get another u substitution where we can just say plus 1 over x, or sorry, minus 1 over x minus 1 plus c. So there you have it. We just use partial fraction decomposition to break down a really complicated problem into these four parts that we can integrate more easily, and then we just end up with this final answer.